Hey guys, Mr. D here, another video. This one is on the trig ratios. So hopefully this is a memorable one, because this is going to be used in a lot of topics going forward, especially if you're going into the harder maths. So what are we talking about here? Sine, cosine and tangent, often shortened to sin, cos and tan, which you'll find as buttons on your calculator. You're probably wondering what they're all about. They are all ratios of sides of a right angled triangle in relation to each other. So for a given angle of interest, which we've been calling theta so far, the ratios of the sides stay the same. Doesn't matter the size of the triangle itself. So what it's saying is that for any angle, if it's given here, it doesn't matter the size of these, the length of these sides. For this particular shape, it doesn't matter if it's a small version, let's say that was 5, 3 and 4, or if they're all doubled, doesn't matter the size of the triangle, the ratio of that side compared to that side is always going to be the same, even if this is bigger or smaller. Okay, so for any given angle theta in a right angled triangle, this is in this box here is the key that you're going to have to remember. The sine of theta, which can be shortened to sine theta, is going to be the opposite divided by the hypotenuse. Opposite over hypotenuse. The cosine of theta, which is shortened to cosine theta, is the adjacent side over the hypotenuse. And the tangent of theta, which is shortened to tan theta, is the opposite side over the adjacent side. So these ratios, sine of theta is equal to the sides divided by each other. Opposite over hypotenuse, cosine of theta adjacent over hypotenuse, tangent opposite over adjacent. So some of you may have heard of the term Sohcahtoa. If you look at these shortenings here, an easy way to remember this stuff is to write the letters starting each of these combinations here. So sine is S, the opposite side O, and the hypotenuse H. So remembering SOH, SO, will help you remember this ratio. Sine of the angle is equal to the opposite over hypotenuse. If you look at this one here, the first letter of cosine is C. The first letter of adjacent side is A, and the first letter of the hypotenuse is H. So CAH, C-A-H, will help you remember the cosine ratio. And lastly, tangent, or tan theta, starts with T. The first letter of the opposite side is O, the first letter of the adjacent side is A. So the last thing you can use to remember the or the tangent ratio is TOA. So if you remember these three letter combinations, you can use it to remember these trigonometric ratios. Okay, Sohcahtoa. Sort of sounds like the name of some sort of volcano or something. So these ratios here are giving us a relationship between the length of the sides, whatever the opposite side is over the hypotenuse, and the angle. So you can see where trigonometry is going to come into it, because trigonometry is the study of the side lengths and the angles in geometric shapes. In our particular case, right angled triangles. So if you know the length of a right angled triangle side, you can find the sine, cosine, or tangents of the angle theta. So let's run through an example here. For the triangle ABC below, one angle is known to be 57 degrees. Find sine of 57. So this triangle, we know 57 degrees is down here. That's the angle of interest, that's theta. 6.8 centimeters is opposite to the right angle, so this is the hypotenuse. 5.7 centimeter side is opposite to the angle of interest, so this is opposite. And 3.7 centimeters is the side that's adjacent to the angle, so label those. So having labeled them and knowing where the angle of interest is, we can use the ratios to work out what the sine, cosine, and tangent of 57 degrees are. So sine is opposite over hypotenuse. Sine, theta is opposite over hypotenuse. We know the angle here is 57 degrees. 57 degrees is equal to, the opposite is 5.7 over, and the hypotenuse is 6.8. And using a calculator, we can work out what 5.7 divided by 6.8 is. 5.7 divided by 6.8. That comes to 0.8382 to 4 decimal places. Okay? Now, on your calculator, you'll notice that you've got a sin, cos, and tan button. If you press the sin button and press 57 and then press enter, you'll find that you'll get the same answer, because it's showing that the ratios are always the same. So if I go to my calculator, I'm going to use the calculator to find what sine of 57 degrees is. Press the sin button and press 57 and then press enter, and you will also get 0.838, slightly off because it's differently rounded, 0.838724 dp using calculator. Alright, so you can see they're pretty much the same. So confirming that the sine ratio is the opposite side over the hypotenuse. Okay, let's find the cosine of 57 degrees. So cosine is the adjacent over the hypotenuse. So the adjacent is 3.7 and the hypotenuse is 6.8. So what is 3.7 divided by 6.8? 0.5441 to 4 decimal points. Let's check on the calculator if we get a similar answer. What's the cosine of 57 degrees? Cosine 57 on the calculator. That comes to the same thing, 0.544, oh, it's pretty close, 4 dp using calculator. And lastly, the tangent, tan of 57 degrees. So the tangent is the opposite over adjacent. 5.7 is the opposite side, and 3.7 is the adjacent. 5.7 divided by 3.7 comes to 1.5405 to 4 decimal points. Check it on the calculator. Tan of 57 degrees, what does that come to? Oh, once again, very close, 1.539994 dp using calculator. Alright, so those slight differences are only coming about because these measurements wouldn't be exactly perfect, but it's just showing you that these trigonometric functions are the sides over each other, and how to use the calculator to find those as well, and they're pretty damn close. Okay, so hopefully that helps you out with trigonometric ratios, and I'll see you on the next video.